Good morning, students. Welcome to the video lecture. Myself, Yildiz P. Jacob, Assistant Professor Chemistry, Department of Science and Humanities, PhysAd. In this video, I wish to discuss the problems related to the Module 1, Electrochemistry and Corrosion. Without any introduction, I am moving to that. Okay, shall we? Yes. Let us read the first problem. Calculate the single electrode potential of zinc electrode at 25 degrees Celsius when the concentration of Zn2 plus is equal to 0.1 molar, 0.01 molar and E0 of Zn is equal to minus 0.76. Maybe this is a problem having weightage 3 marks. So I will explain how this marks is split into subsections. As an engineering student or as a student, first thing you should be written in your paper is given data. You have to crack the problem and write what are the given data. Here, when you read this problem, we need to calculate the single electrode potential of Zn and temperature 25 degree. So first data is here the temperature is given as temperature is equal to 25 degrees Celsius. It is equal to 298 Kelvin. Which means that this is a standard condition. And another thing which is given that the concentration of Zn2 plus is equal to 0.01 molar. The second data is concentration of Zn2 plus is equal to 0.1 molar and E0 of Zn, that is normally Zn2 plus bar Zn, which is equal to minus 0.76. These are the data given for us. So using these data, we need to calculate the single electrode potential. Shall we move to that? How? The second point, if you write these, you get a small marks. Normally you got maybe 1 to half marks. Half to 1 marks you may get. Okay. So second thing is you should write the equation. Equation need to be written. Okay. So from here the concentration value is given for us and you need to calculate the electrode. If you combine these data, we can say that we need to apply the Nernst equation. What do we have to apply? Nernst equation. Okay, so when you write this Nernst equation, we can written that E cell is equal to E0 cell minus, this is a standard condition, so you can write is 0.0591 by n log. For a single electrode, the equation will be log 1 by concentration of Mn plus. That's the equation. Just substitute the values, then we can return as E cell is equal to E0 cell. It is given that is minus 0.76 minus 0.0591 by, we need to calculate the value of N. How? Here we know that the zinc undergo oxidation or reduction. Here it is reduction potential. The reaction will be Zn2 plus 2 electron giving Zn, giving Zn. So from that, it is clear the number of electrons n is equal to 2. So here we can substitute n value as 2. Then just put log 1 by concentration of 0.01. When you solve this session, we get the answer as 0.059. So we can say that when you substitute this value here, we can say that the single electrode potential is equal to minus 0.76 minus 0.0, get that as 0.059. So the answer will be minus 0.819, should be written the unit as 0.819, that is minus 0.819 as the answer. So the half mark is for the given data, and half mark is for the equation, and then 1 mark is for the substitution and 1 mark is for the final answer. You got the problem? Yes. Let us move to the next problem. If you read this, it's clear that write the cell reaction, cell representation of copper Ag cell. That is the first thing. Second thing is calculate the EMF of the cell where copper concentration is equal to 0.01 molar, concentration of Ag plus is equal to 0.1 molar. Given that copper concentration is zero value, copper E0 value is equal to 0.34, that of Ag is equal to 0.80. First, we need to write the cell reaction and cell representation. Before we need to write the cell reaction and the cell representation, first of all, you need to calculate whether the electrode is, which among the half cell is anode or cathode. We know that E0 of copper is equal to 0.34, that of E0 of Ag is equal to 0.80. Which is the large value. Without any doubt, we can see that 0.80 is the larger value, larger reduction potential. And here 0.34 is the lower reduction potential. Among these, 0.80 is big, so we can say that this Ag will behave like, not behave like, it behaves as cathode. It behaves as cathode. At the same time, copper behaves as anode. Why we say like that? Those electrode having higher reduction potential behaves as cathode. Those electrode having lower reduction potential behaves as anode. So first thing, we will get the cell reaction and cell representation. So shall we write? Yes. The first thing is, let us write the cell. First of all, we have to write the cell representation because it is easy. Cell representation. I am writing the short form. When you write the cell representation, first of all, you need to write the data of anode. Then, if any salt bridge you have to put that, then you have to write the data about cathode. When you're dealing about anode, first you have to write the metal, then you have to write the ion. So anode എന്ന് പറയുന്നത് copper ആണ്. So let us start with the cell representation with copper metal. So Cu, it is in the form of solid bar. What about the solution? From which it's clear that the solution is Cu2 plus. Most of all, this is in aqueous form, double bar. Then we have to write about cathode. What about the cathode? That is Ag plus. Here it is also represented like this. ഇത് തന്നിരിക്കുന്നത് cathode representation പോലെയാണ് രണ്ട് തന്നിരിക്കുന്നത്. But here കോപ്പറിന്റെ കേസിൽ മാത്രം ആദ്യം മെറ്റൽ എഴുതണം, അത് കഴിഞ്ഞ് കാരണം ആനോഡിന്റെ കേസ് എപ്പോഴും ആദ്യം മെറ്റൽ അത് കഴിഞ്ഞിട്ട് അയോൺ എഴുതണം. Here in case of cathode, first of all you have to write the ion, then metal. Here the ion is Ag plus, so we can write it Ag plus bar Ag. ഇത്രയും എഴുതി കഴിഞ്ഞാൽ you will get 1 mark. Okay, next one is you have to write the cell reactions. Second point എന്ന് പറയുന്നത് cell reaction നിങ്ങൾ എഴുതണം. Cell reaction എഴുതണം. Okay, cell reaction എഴുതുന്നതിന് വേണ്ടിയിട്ട് എന്താ ചെയ്യേണ്ടതെന്ന് വെച്ച് കഴിഞ്ഞാൽ we know separately we need to write anode and you need to write cathode. രണ്ടും സെപ്പറേറ്റ് ആയിട്ട് എഴുതണം. Anode reactions and is oxidation reaction. Copper undergo oxidation രണ്ടും ഇവിടെ തന്നിട്ടുണ്ട്. The changes is represented here Cu to Cu2 plus. So anode reaction എഴുതാൻ വേണ്ടിയിട്ട് വേറെ ഒന്നും ചെയ്യേണ്ട ആവശ്യമില്ല. Just you have to write the left side, that is copper, then right side, that is copper 2 plus, then put an arrow mark, then think copper is converted to copper 2 plus. How? By releasing 2 electrons. By releasing 2 electrons. That is anode reaction is over. Then you need to write the cathode reaction. Here the cathode is Ag plus, representation is Ag plus is first of all. Then Ag plus is on the left side and right side is Ag. You have to write the, put the arrow mark. Then think how this Ag plus is converted to Ag. Yeah, it is by the conversion or by accepting 1 electron. There is a problem. What is the problem? Here we know that the number of electrons donated should be equal to the number of electrons donated should be equal to number of electrons accepted. So here is 2, it is 1. So we need to multiply this equation by 2 and we are rearranging. So we will get 2 Ag plus 2 electron giving 2 Ag. Then we can cut these 2 electrons and 2 electrons. Then sum ചെയ്ത് എഴുതുമ്പോൾ നമുക്ക് എന്ത് കിട്ടും? Equation is first of all Cu plus, so ഇവിടെ ലെഫ്റ്റ് സൈഡിലെല്ലാം തീർന്നു, ഇവിടെ ഇനി എന്തുണ്ട്? 2 Ag plus ഉണ്ട്. എന്തുണ്ട്? Here its remaining is 2 Ag plus. 2 Ag plus gives Cu2 plus 2 Ag. This is the cell representation. Next thing എന്ന് പറയുന്നത് you need to calculate the cell reaction, EMF of the cell. We know that here the concentration values are given. So you without any doubt we can say that we are using what? We are using Nernst equation. The general format of Nernst equation is E cell is equal to E0 cell, V0 cell minus 0.0591 by n log, from the equation it is we can write it as concentration of product divided by concentration of reactant. So when we can write it as here P by R as concentration of Cu2 plus divided by concentration of Ag plus square. Why? Because there are two Ag atoms. We know that by convention the concentration of Cu is equal to 1 and concentration of Ag is equal to 1. We don't need to put it here. So then we need to calculate the E0 value. Let us calculate the E0 value as E0 is equal to E0 cathode minus E0 anode. Cathode is Ag. So we can write 0.80 minus 0.34. We get the answer as 0.46 volt. Then P by R, concentration of Cu plus. What about that? The value is equal to, concentration of Cu plus is equal to 0.01 divided by 0.1, the yes, 0.1 square, that is equal to 0.1 square is equal to, what about the value of 0.1 square? Yeah, 0.01 divided by 0.01. So it will get, we'll get the answer as 1. So let us substitute these values. We get we can rearrange or we can substitute all these values. Then we can write E0 value. We got it as 0.46 minus this value 0.0591. The whole divided by number of electrons is 2 into log 1. Log 1 value is 0. So the entire term become 0. So we will get E cell is equal to E0 cell. So E cell is equal to 0.46. That is the answer. What is the unit? 0.46 watt. That is that we got the problem. Okay. Yes. Let us move to the next problem. Shall we? Shall we move to the next problem? Yes. Next problem is calculate the equilibrium constant of Daniell cell reaction if E0 cell of Daniell cell is equal to 1.1 volt. There is no any data are given here. The only data given is that is 1.1 volt is the E0 value. So using these values, you need to calculate the equilibrium constant. Shall we move to that? Let us see how we can do that. Okay. Yes. From this, first of all, you need to write the basic ideas. The basic idea is only the thing is that cell is Daniell cell. So we know that for a Daniell cell, just I am changing the color. Okay, for a Daniell cell, that is the Daniell cell, the number of n is equal to 2. That is the first thing. And the E0 value is equal to 1.1. These are the only the data given for us. Then the main idea is you need to calculate the equilibrium constant. We need to calculate the equilibrium constant. ഇത് കണ്ടു കഴിഞ്ഞ് വേറെ ഒന്നും നോക്കണ്ട. At equilibrium, the value of E cell is equal to 0. So from Nernst equation, we can write as E cell is equal to, we know that the investigation as E cell is equal to E0 cell minus 2.303 RT by NF log concentration of product divided by concentration of reactant. We know that. Then we know that this value becomes 0, and substitute the standard condition, we can return as E0 cell, and the condition is a standard potential, so we can return as E0 cell is equal to, so we can E0 cell is equal to 0.0591 by N. Here P by R we can return as it as a constant, so the equilibrium constant. We need to calculate this by substitute. We know that the N is equal to 2. By substituting we get it as, so 1.1 is equal to 0.0591 divided by 2 log K. So we get log K is equal to 1.1 into 2 the whole divided by 0.0591. The answer is 37.22, just 37.22. You can do using your computer. So log K is equal to 37.22. So K is equal to anti-log of the value 37.22. So the answer will be 1.67 into 10 raised to 37. For equilibrium constant, there is no unit. Only thing should be remind that the concentration, or sorry, the E0 value is 0. E0 not, E cell value is 0. And this, for all problems the strategy is same, but you have to check the number of electrons. Okay. Next, I am moving to the next problem. Here, calculate the amount of electrical energy available from the dry cell of EMF 1.5 volt, which consume 10 gram of Zn. Given that atomic weight of Zn is equal to 65. 10 gram സിങ്ക് ഉപയോഗിച്ചിട്ട് അല്ലെങ്കിൽ കൺസ്യൂം ചെയ്ത് ഒരു ഡാനിയൽസൺ വർക്ക് ചെയ്ത വാട്ട് വിൽ ബി ദ വാല്യൂ ഓഫ്, അല്ലെങ്കിൽ how much electrical energy is produced? We know that the electrical energy produced is the expense of free energy change decreases. എന്ന് പറഞ്ഞാൽ ഡെൽറ്റ ജി എന്തുമാത്രം കുറയുന്നു അത്രയും electrical energy avade form cheyunu. That is the basic idea to do this problem. So here we need to calculate the value of delta G. What is the equation for delta G? We know that. What is the equation for delta G? Delta G is equal to, what is the equation? Minus N F E cell. Right? For Daniel cell, for a dry cell, we know that N is equal to 2. For a Daniel cell, N is equal to 2. The simple thing, the value of N is equal to 2. Ready? So let us substitute the values. Just substitute the values, then we can write delta, just a sec, okay, delta G is equal to minus N is equal to 2 into F is 96500 into, what about the value of E cell? That is equal to 1.5. Let us substitute, we got the answer as 2, 8, 9, 5, 0, 0. Delta G is equal to, what is the delta G means? Delta Gibbs free energy. What is the unit of energy? It is joule. And another thing is that this much electrical energy produced or this much free energy is produced by the consumption of 1 mole substance. എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ 1 mole substance reaction നടന്നു കഴിഞ്ഞാലുള്ള ഇക്വേഷനാണ് എഴുതിയിരിക്കുന്നത്. By considering the mole concept, we can write that is as 1 mole. So atomic weight of zinc is equal to 65.5. So by convention or by if we are considering the mole concept, we can say that 65.5 gram of Zn can produce this much, that is 2, 8, 9, 5, 0, 0 joules. In the problem, we need to calculate 100 gram. So that is 10 gram of zinc produce. Electrical energy is equal to 2, 8, 9, 5, 0, 0 into 10 into 10 the whole divided by 65.5. Why? ഈ പ്രോബ്ലത്തിൽ നിന്ന് 65.5 ഗ്രാം സിങ്കിൽ നിന്ന് നമുക്ക് എന്ത് കിട്ടുന്നു? 28.9500 കിട്ടുന്നു. സോ ഫ്രം 1 ഗ്രാം കണ്ടുപിടിക്കാൻ വേണ്ടി എന്ത് ചെയ്യണു? ഈ പറയുന്ന 2895 എന്ന് പറയുന്ന ഈ വാല്യൂവിനെ 65.5 വെച്ച് ഡിവൈഡ് ചെയ്യുന്നു. So for 10 gram into 10. So the answer will be, anybody please? What about the answer of the problem? Which is equal to, this is a problem value? Yeah, that is 44198. What is the unit? Joule. The problem is finished. Let us move to the last problem. Calculate the single electrode potential of zinc electrode when the concentration of Zn2 plus is equal to 0.1 molar at the temperature 50 degrees Celsius. The main crook or main ഈ ഒരു പ്രോബ്ലത്തിന്റെ ഏറ്റവും വലിയ പ്രശ്നം എന്നാണെന്ന് വെച്ച് കഴിഞ്ഞാൽ ഇവിടുത്തെ ഈ വാല്യൂ ആണ്. ഇവിടുത്തെ ടെമ്പറേച്ചർ വാല്യൂ ഈസ് ഈക്വൽ ടു 50 ഡിഗ്രി. നോർമൽ സ്റ്റാൻഡേർഡ് ടെമ്പറേച്ചറിൽ നമ്മൾ യൂസ് ചെയ്യുന്നത് 50 ഡിഗ്രിക്ക് പകരം നമ്മൾ 25 ഡിഗ്രിയാണ്. ദാറ്റ് ഈസ് ദ മെയിൻ ഡിഫറൻസ്. So from this concentration ഒക്കെ തന്നുകൊണ്ട് we can say that the problem which is we are using is Nernst equation. So we can write Nernst equation as E cell is equal to E0 cell minus, so the normal equation അല്ലാത്തതുകൊണ്ട് നമുക്ക് എങ്ങനെ എഴുതാൻ പറ്റും? 2.303 R T divided by NF log single electrode potential ion equation is 1 by concentration of Mn plus. By substituting the values, we got it as E0 value is given as minus 0.76 volt. ഇതിലെല്ലാത്തിലും നമ്മൾ എന്ത് ചെയ്തോളണം? You have to give the given data. So from the given data, minus 0.76 minus 2.303 into R, that is 8.314 into T. T എന്ന് പറയുന്നത് 50 ഡിഗ്രി ആണ്. 50 ഡിഗ്രി നമ്മൾ എന്ത് ചെയ്യണം? You need to convert it into Kelvin, that is equal to 50 plus 273. That is equal to 370 that is 370 323 Kelvin എന്ന് ഉത്തരം കിട്ടും. Just substitute this value, that is 323, that divided by n value is should be that is 2, because Zn2 plus is converted to Zn. Number of electrons is equal to 2 into F is equal to 96500 into log 1 by concentration of Zn is equal to 0.1. So we get the answer as, just solve it, you will get the answer as minus 0.792 volt. So here mainly we are using the Nernst equation. Nernst equation use ചെയ്യുമ്പോൾ നിങ്ങൾ ശ്രദ്ധിക്കേണ്ട മെയിൻ കാര്യം എന്ന് പറയുന്നത് ഇത്ര മാത്രമേ ഉള്ളൂ. Just check the concentration values, just check the temperature. If the temperature is 25 degree, then we can use the equation as 0.0591 എന്നുള്ള ആ equation നമുക്ക് ഇവിടെ യൂസ് ചെയ്യാനായിട്ട് സാധിക്കും. So that's about today's class. Thank you.